Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's average level difficulty puzzle called Cathedral by Jobo. And here are the rules. Normal Sudoku rules apply, which means place digits 1 through 9 once each in every row, column, and 3 by 3 box. Digits along an arrow must sum to the digit in that arrow circle. So for example, these 3 digits must sum up to the same as this digit. Same for these 3 digits, they must sum to this digit, and etc, etc. Box borders divide blue lines into segments with the same sum. So basically, for example, in this long line, these 2 digits must equal the same as these 3 digits, which must equal the same as these 5 digits, which must equal the same as these 2 digits, which must equal the same as these 5 digits, etc, etc. So for example, these 2 digits do not equal the same as these 5 digits, even though they're in the same box, because the box borders divide the line into segments with the same sum. So this is a separate segment from this one. Digits separated by an x must sum to 10. So these 2 digits must sum to 10. Not all x's are given. So that's only positive information that we're given here. We're only given information about these 2 digits and these 2 digits that they must both sum to 10. There could be 2 other cells or many other cells in the grid which also add up to 10, but we know just specifically about these 2 and these 2, they must add up to 10. Cells separated by a king's move cannot contain the same digit. So in addition to the regular Sudoku rules, and usually actually this only applies to cells across borders, essentially. Because if for example, you had a 5 here, by normal Sudoku rules, because of the box, you would not have a 5 anywhere there. But in addition, if you have a 5 here, say, that would mean there cannot be a 5 in any of the surrounding cells. Let's make that red. So there cannot be a 5 in any of the surrounding cells because that's a king's move away. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so box borders that, as I highlighted earlier, these 2 equals the same as these 3, which equals the same as these 5. So since it's 5, and it must be 5 unique cells, that means it has to be 1 through 5 at least. So then it'd be 1 plus 2 plus 3 plus 4 plus 5, which is 15. And since it must equal a 2 digits, that means it's 17 at most. So the 5-digit sets have to be 1 through 5. Or sorry, have to be at least 1 through 5, but at most 1 through 7, which means these 2 digits have to be add up to 15 at least, and can only add up to 17 at most. Therefore, we know 1 through 3 have to be in the set of 5s that are separate. So, for example, so this could be only 1, 2, 3, 4, 5, 6, 7, but we know 1, 2, 3 have to be in that set of 5. So therefore, this cannot be 1 through 3. This cannot be 1 through 3. Same here. This has to be 1, 2, 3, 4, 5, 6, 7. This cannot be 1 through 3. And this cannot be 1 through 3. Lo and behold, here, in row 1, where is the 1, 2, and 3? It has to be in those 3 cells. Because there's no other ones in row 1 which allows us to get 1 through 3. In addition, we know this is 6 through 9, this is 6 through 9, this is 6 through 9 because it has to be 2. This can't be 4 or 5 because anytime you have 3 unique digits in a regular Sudoku, which add up to 1 digit, the 1 digit must always be 6 through 9. So same here. This is also 6 through 9. And these have to be 1 through 6. These are 1 through 6. And these are 1 through 6. Because they can only be at most 1, 2, and 6 to add up to 9. There's no 5 here. This is also 1 through 7. Because this is a 5 set. Which adds up to the same as this. Which would have to be 15 to 17. So this is also 4, 5, 6, 7, 8, and 9. But this can't be 5, and this can't be 5. So this is 1, 2, 3, 4, 6. And this is 1, 2, 3, 4, 6. So this cannot be 1 plus 2 plus 3, because that's 1 plus 2 plus 3. So this cannot be 6. It's one of 7, 8, or 9. One thing is, this cannot be 15. If this is 15, that would mean this would have to be 1 plus 2 plus 3 plus 4 plus 5. Which would mean this would be 6, 7, 8, 9. But this would also have to be 1 plus 2 plus 3 plus 4 plus 5. So this would also be 6, 7, 8, or 9. And then we would not have a 4 or 5 in row 1. So the same process for that, you can't have 16 because those also require the same 5 numbers, which would mean that so you'd have the same 5 numbers here, you'd have the same 5 numbers here. Therefore, this has to be 17. This has to be 17. Because the only way we can get in row 1 a 4 on one side and a 5 on the other side is if it's 1, 2, 3, 4, 7 and 1, 2, 3, 5, 6 on the other side. Therefore, we can get 4 and 5 in row 1. So this has to be 17. So the 5 set must add up to 17, which means the 2 cells must add up to 17. So this has to be 8, 9. So this is 8, 9, 8, 9. This is also 17, interestingly enough. So this is, one of these is 17. Okay, so all of these are 17. This is 17 plus 17, which means that it's 34. So in box 6, the 2 segments that are on the box borderline, or I think it's called region sum lines, must add up to 34. And it's the same for box 4. Because of that, we know it's 14. So it's 34. So these 5 must add up to 11. These 5 must add up to 11. Right? Because this is 17, this is 17, that's 34. The rest of the box the total of the box is 45, so the rest of the box must be 11, which is, if you have 4 digits, can only be one scenario, which is 1 plus 2 plus 3 plus 5. Therefore, this we know is 1 plus 2 plus 3 plus 5. 1, 2, 3, 5, and it's the same here. So this has to be 1, 2, 3, 5, but this can't be 5, and this can't be 5. Therefore, this is 1, 2, or 3. So this could be 6. Actually, no, it has a 5. So it's either 1, 2, 5 or 1, 3, 5. Right? Because it can't be 2, 3, 5 because that add up to 10. Therefore, this is 8 or 9, and this is 8 or 9. So this is 1, 2, 5 or 1, 3, 5. So therefore, this can't be 1. This has to be 7, 8 then. This can't be 1. So this also has to be 7, 8. Which means this is 9. So this is 9, which means this could be anything. This can't be 7, 8, or 9. This can't be 7, so it can't be 4 either. So therefore, this has to be 4. So this has to be 1, 2, 3, 5, 6, because there's no 7 here, there's no 7 here, there's no 2 or 3, there's no 2 or 3. There is no 2 or 3. There is no 2 or 3. Therefore, we have a 4, 6 on the outside, and a 4, 6. This has to be 4, 6, and 7. That can't be 4. This is 4, 6, and 7. That can't be 4. No 4, 6, or 7. No 4, 6, or 7. No 4, 6, or 7 here either. So this can't be 4. Therefore, it's either 1, 2, 6 or 1, 3, 5. So it cannot be 1. That can't be 1. This is 2 or 3. This is 2 or 3. So there cannot be a 2 or 3 in the rest of the row. So this has to be 7 or 8 because those are the only places left in column 5 that can have it. This can't be 8 because we have an 8, 9, 8, 9 pair in row 3. Therefore, this is a 7. This is an 8. So this cannot be 7. This cannot be 7. Oh yeah, this can't be 8 and 9 because we have an 8, 9 pair here. Same here. There's an 8, 9 pair here, so that can't be 8 or 9. So this is 8 or 9. Oh, this can't be 8 or 9 because there's an 8, 9 pair here. Therefore, this is a 5. So since this is a 5, The only possibility for this to be is 1, 2, 3, 4, 7. So there is no 5. Oops, there is no 5. And there's no 6 here. So this can't be 5. This can't be 4 or 7. So this has to be a 6, which means that can't be 6. Right, we have the 8, 9, 8, 9 pair. This can't be 5 or 6. This can't be 5 or 6. This can't be 5 or 6. We have a 4, 7. So this cannot be 1 plus 2 plus 3 plus 4 plus 7. So this has to be 5 and 6. So 4 and 7 are here. This is 8 or 9. So this cannot be 8 or 9. So we have an 8, 9, 8, 9 pair in box 1. Therefore, this can't be 8 and 9. So that has to be 4 and 7. This adds up to 13, but there is no 4, 6, or 7. It has to have an 8 or a 9, and it has to add up to 17. Okay, that's interesting. This has an 8 or 9. This has an 8 or 9. This cannot contain an 8 or 9. So this is 1, 2, 3, 4, 5, 6, 7. This cannot be 4, 5, 6, or 7. This can't be 6. This has to have a 1 and a 5, so this cannot be 1 or 5. This can't be 1. And again, this can't be 1 or 5 either. Okay. This is 1 through 7. This cannot be 1 in box 8 because this has to have a 1 here. So this is 2 through 9. This can't be 9 because of King's Move. Oh yeah, King's Move stuff. No, 2, 3, 4, 5, 6, 7, 8. This can't be 9, so one of the 9s is there. This has no 4, 6, or 7. It must have an 8 or 9 and a 1, 2, 3, 4, 5. This cannot have 1 or 5. This could be 2, 3, 4, 6, 7, 8, 9 with that. Okay, so we know this adds up to 17. What are the possibilities for 17? If it's 8, it has to be 3. It can't be 8. If it's 8, that doesn't work, right? It has to add up to 17. So 17 minus 8 would be 9. But you don't have you don't have 1 8, you don't have 2 7, you don't have 3 6 or 4 5 as possibilities. Therefore, this cannot be 8. This has to be 9. The only ones that add up to 17 would be 3 5 and 9. So this is 3 5 9, which means there's no 3 5 here, which means this is 8. This has to be 9, so therefore this has to be 1 3 and 5, which makes this is a 2. So this has to be 8 to add up to 10. This is a 7. This is a 3. This has to be an 8 because of this 9 eliminates the 9 here. So this is a 9. This has to be 1, 2, and 5. Because of the King's Move rule, this cannot be an 8, so this has to be a 9. So therefore that eliminates a 9 here. So this is an 8. This is a 9. This is an 8 because of the King's Move. We have a 1 2 pair in box 1, therefore none of the other cells in box 1 can contain a 1 or a 2. This can't contain a 3 because of that 3. This can't be a 3 because of King's Move. This can't be a 2 because of King's Move. There's no 3 or 5 here. No 3, no 9. This can't be a 2, 3, or 5 because this has to be 3 or 5. This can't be a 2 because of King's Move. This can't be a 2 because of King's Move. This can't be an 8 because of that 8. This can't be a 3 because of King's Move. And this can't be a 7 because of that 7. This can't be a 3 because of that 3. No 3 because of King's Move. No 7 because of King's Move. So then we have what's left. This is 4, 5, 6, and 9. But this cannot be, so the 9 has to be one of these two. This is also 4, 5, 6, or 9. That 6 was eliminated by King's Move. Okay, so this is 17. This is 17. This is 1, 2, or 3. This is 1, 2, or 3. There has to be a 5 here. Because of King's Move, none of these can be 5, right? If this is a 5, that sees it because of Sudoku, or King's Move, actually. So this one sees both of these squares because of King's Move. This one sees both of these squares because of King's Move. Therefore, and since the 5 has to be there, Actually, in fact, where's the... Okay, this can't be 3. This has to be 6. Um, so this can't be 6. This can't be 6 because of this 6. So this is 3 or 5. This can't be 6. So 3 and 5 cannot be both here. So 5 can't be here, which means that 5 has to be one of those two, which means neither of these can be 5. That can't be 5. So the 5 has to be one of these two. The 6 has to be one of these two. Okay. So this is 9. Therefore, this and this must add up to 36. Okay. That's quite varied. Oh, we know this is... Well, that doesn't help. Okay, so then... This has to have an 8. I don't know if that helps us any. And this is the same sum as that. This could be at least... This has to be at least 6. So this is 17 plus at least 6. So that's 23. Right? 17 plus 6, at least 6 is at least 23. So this is at most 22. Okay. This is 18. This is at least 5. So that's 22. So this is at most... Okay, it cannot be 23. So this cannot be 1 and 4. This is at least then 1 and 6, right? We tried 1 and 4 plus 17. That would be 22, but then this would have to be 23. And that's not a... That doesn't work. Because it would have... Oh, wait, there's 4 digits. Well, but this can't be 23 either. Because this would have to be 6, 8, and 9, and that's not possible. So it cannot be 1 and 4. It could be 1 and 6. If it's 1 and 6, that would mean... Okay, so this can't be 2 also. This can't be 2. Interesting. If this is 1 and 6 here, that'd be 18 plus 6 plus 7. Sorry, 17 plus 7, which would be 24. Therefore, this would equal 21, and that's possible to be 6, 7, and 9. Oh, but it's not 6, 7, or it could be... It can't be 5, 8, 9, can't be 6, 7, 9. So this cannot be 1, 6 either. So 1, 7 is possible, though. Okay. The 5 has to be here. This has to be 8. What does that mean? 2 or 3 has to be on one side or the other. Even... Well, okay, what's the maximum with 3, 8, and 9? It's 20. But this doesn't have to contain the 3 here. In fact, well, we don't know. In row 5, you cannot have... You have 1, 2, 3, 5, and 6 making up 5 cells. And that's 5 unique digits in 5 cells. Therefore, there cannot be a 1, 2, 3, 5, 6 in the rest of row 4. So this has to be 4, 7, 4, 7. That doesn't really tell us much, but at least that's some information. This is 6, 7, 6... Oh, so this can't be 6. We have a 6, 7, 6, 7 pair in row 5. That eliminates 6, 7 in the rest of the row. Yeah, I think we just have to do the sum of this part. That's going to be that's a lot of calculation. Okay, so this is 9, so these two add up to 36. Hmm. Yeah, it's just that's gonna be has to be calculation. I don't like these the most. Okay, what are the possibilities? Okay, so this has to have a 6. Does a 7 have to be here is the question. Probably not. If this is 7, this would have to be 1, 7, 1, 2, 7 at the least. Right, if you have the most, obviously, it's probably not going to be valid. In fact, you can't. Yeah, one of these has to be 1 or 2. Um, so the most would technically be like 2, 5, and 7, I guess. Hmm. Interesting. So if this is 3, this has to be 4, 6, 7, which would make that 3, which would make that 7. But that doesn't... Oh. That would make that 4, which means that cannot be 4. That's interesting interaction. So say this was a 3, right? That's 3 in the corner. This would be 4, 6, 7, which would mean this cannot be 4, 7. This would have to be 3. That would have to be 7. This would have to be 4. This cannot be 4. Therefore, since this can't be 4, this can't be 4. This would have to be 6. This would be 4. Oh, that's interesting. Because of this 4, this would have to be a 6. Which means this is 5 and this would be 9. So this could not contain a 9. It would have to be... Oh. Ah, okay. I see it. I see the king's move logic. This can't be 6 still. 6 is only here or here, right? Since 6 is only here or here, they both see that cell from king's move. So therefore, this has to be 5, which means this cannot be a 5. This can't be 5. Oh, this can't be 3 or 5. It can't be 1, 3, or 5. So this has to be 1, 2, 6, which makes this a 3. So this can't be 3. This can't be 3. There can't be a 2 or 6 anywhere else in box 8 because we have a 1, 2, 6 triplet there. This can't be 5. This can't be 5 because of this 5. This is 4, 6, 4, 6. So this cannot be 4. So this is a 9. This is a 5. That's a 3. This is a 5. This can't be 3. This can't be 3. Where can 3 be in column 8? It has to be here. So this cannot be 3 either, which makes this the only 3 possible in column 9. 9 can't be here because of this 9. Therefore, this has to have a 9. Okay, so we've got all that. That was interesting. I like that king's move. This can be at most 4, 5, and 7. So that would be value of... Can it be 3, 4, 5? No, I don't think so. No, it cannot be 3, 4, 5. Oh, well, we also know the 7 has to be there. That's not helpful. So it's either 3, 4, 7, 4, 5, 7, 3, 4, 7, 3, 5, 7, or 4, 5, 7. Okay, that limits things a lot. And this has to be 8 and 9. Oh. This has to be 8 and 9, and it's with 3 or 4. So this adds up to 20. Okay, so this has to be 5 and 7 with 3 or 4. Okay, so this is at most 4, 5, 7, which would be 9 plus 7, which is 16. So this is at most 16, which adds 16 plus 17 is 33. So we have two digits that have to be at least 12. So therefore, this has to be 1, 6, 7. So that forces this to be 4, this to be 1, this to be 7. That can't be 1 because of King's move, so that's a 5. This can't be 5. We have a 1, 3, 1, 3 pair in row 5, therefore there cannot be a 1 or 3 in row 5. So this has to be a 2, this is a 5, this is a 1, this is a 2. This can't be 2, this can't be 2, this has to be a 1 because of this 2, this has to be a 2. This can't be 1. This can't be 1, this can't be 1 because of this 1. This can't be 1 because of King's move. This can't be 7 anymore. This is 1, 2. This can't be a 5 because of King's move. This is 1 plus 2 plus 4 plus 8, which adds up to 15. So therefore, this has to be 3, 5, and 7. So this can't be 3 then, because we have all 3, 5, 7 triplet here, and there can no longer be 3, 5, 7 in the rest of the column. So this is 1. This is 6. This is a 3. And the rest we're getting through Sudoku. Well, this is 4, 8, 9. This has to be a 4. This is a 6. This has to be a 1 because of the King's move. So this is a 1. This is a 2. This is a 1. This is a 2. Which makes this a 1. Which eliminates 1s in box 9. This can't be a 1. Therefore, the 1 can only be here in column 5. This is a 1. This is a 3. Again, this can't be 2. This is 4 plus 8 plus 9. So this adds up to 21. So this adds up to 21. We have 21 plus 1 is 22. 22 plus 17 is 39. So this must add up to 6. So this has to be 2 and 4. So that 2 and 4 eliminates any 2 and 4. That 2-4 pair eliminates any. So first of all, also from King's move, these can't be 4. Because this sees these two. Actually, this sees all 3 of these. So all 3 of these means this can't be a 4. So this has to be a 2. This has to be 4. This is a 5. This can't be 2. This can't be 2 in column 2. The only 2 can only be here. Therefore, this is a 6 now, which makes that a 2. This has to be 7, 4, and now we're just doing Sudoku. So that's 7, 6. This can't be a 4 because of King's move. This is a 4. So that's an 8. Sorry, now we're just doing Sudoku. Normal Sudoku. So this has to be 9. This has to be 8. This has to be 9. This is an 8. The 7 can only be here. Oh, because that was also Knight's move. Or King's move. Okay. Now we really are only doing Sudoku here. This is 3, 6, 3, 7. Actually, I lied again. This is the 5. This is a 3, 5, 9. This 6 means this cannot be a 6 because of the King's move rule. So that's a 4, which makes that a 7, which makes that a 6, which makes that a 7, a 4, and a 6. And that's a solve. Sorry about that. There was a lot of King's move there at the end to differentiate the possibilities there. Anyways, I hope you enjoyed, and I'll see you next time on Frank Puzzles. Take care.